Physics but simple. So imagine this for a second. You are standing outside during a storm and suddenly a lightning strike cuts across the sky. It's powerful, dramatic, and honestly a little scary. But here's the weird part. That lightning didn't just appear randomly. It's actually a perfect example of something invisible shaping our world. Now that raises a very interesting question. How can a force even exist across empty space? Like nothing is there. So how is something happening? It almost feels like a force coming from nowhere, right? But to understand this, let's take a step back and look at something more familiar. Gravity. We don't see gravity, but we feel it every single day. What's actually happening is this. Any massive object like Earth creates an influence in the space around it. We call that a gravitational field. And electric fields, they work in very similar way. Except instead of mass, they come from charge. So now we are stepping into this idea of an invisible influence. An electric field exists in the space around a charged object. You don't see it, you don't hear it, but it's there, quietly affecting anything that enters that space. In fact, you can think of it like this. A charged object creates the field, and then we use something called a test charge to detect it. Kind of like sending in a tiny spy to see what's going on. If the test charge feels a force, then congrats, you've just found yourself an electric field. Now, to make this more precise, we define the electric field E as the force experienced per unit charge. In simple terms, it's like asking, how strong is this field at this point? So mathematically, we write it as E equals F divided by Q. Clean, simple, and slightly intimidating if you see it at 3 a.m. during exams. But here's where things get really interesting. The electric field doesn't need the test charge to exist. It's already there. The test charge just helps us notice it. So even in empty space, the field is quietly present, just waiting to interact with something. Now, since we can't see electric fields directly, physicists came up with a clever way to visualize them. Electric field lines. These lines show us the direction a positive charge would move. They always start from positive charges and end at negative ones. And the spacing of these lines, that tells us the strength. If the lines are packed closely together, the field is strong. You'll also notice different patterns depending on the charges involved. Opposite charges create these beautiful curved lines that connect them, while like charges push the lines away from each other. It's basically physics confirming what we already know. Some things just don't vibe. And here's the coolest part. Electric fields aren't just some abstract concept. They are everywhere. Your phone, your electronics, even the air during a thunderstorm. Everything involves electric fields. The strength of these fields can vary a lot. For example, the electric field in normal air is relatively small, but during a thunderstorm, it becomes incredibly strong. Strong enough to create lightning. Electric fields are also responsible for things like photocopiers, static electricity, and even holding atoms together. So from tiny particles to massive storms, electric fields are constantly shaping the world around us. So the next time you see lightning, or even just get that tiny shock when touching a doorknob, just remember, it's not random. It's the invisible influence of electric fields quietly doing their job all around you. And honestly, once you start noticing it, empty space doesn't feel so empty anymore. Physics, but simple.